Everyone, I hope you're having an amazing day. Welcome to another episode of Einstein Analytics and Machine Learning. So the first part I'm going to talk about Einstein, and then the second part we're going to jump into machine learning. So if you haven't watched my previous video, I will highly encourage you to do so because the previous lecture is a prerequisite for today's one. Cool. So what we're gonna do today on Einstein, we're gonna jump into the dashboard which we have created last time, and we're gonna add filters, and then we're gonna talk about the page links, moving back and forth. Right? Cool. Sounds good. All right. The first thing first, you need to log into your org. So if you haven't watched my previous video about how to log into how to set up an org for Einstein, I would highly encourage you to do so. Cool. I'm in my Einstein org, so let's go to Analytics Studio, and let's go to the app which I created in the last lecture. And we have created two things. One is the data set and one is the demo dashboard. So we're gonna go to demo dashboard, and then this is what we have, right? Nice and easy. Now, if you remember that I've used the lead as a data source, and I have grouped this by lead source. That's the partner, referral, phone inquiry, purchase list, and web. Now, you give this to a client. Client says that looks great, but I wanted to have more options. Right, I wanted to filter this using a lead source. I wanted to see only web. I wanted to see only purchase list. Can we do that? Yes, absolutely. So what we're going to do, we're going to go to this edit, and then there is a list here. Drag this boy here, right, and then double click on the list, and we select the lead source which we wanted to filter by, and we change the title to this is a property of the list, to say filter. Excuse me. And then you can add some styling as well. If you don't want combo box, you can change the combo box. If you wanted the field text color to say blue, you can do that. You want the value text color to be red, you can customize the way you want, right? So it's pretty straightforward. It's up to you what you wanted to do with that, with your style and that kind of stuff. So I'm not gonna get into those stuff here for now. Okay, I'm gonna save it. Excuse me. And then please make sure you save into your right app, right? Cool. Save, and it's gonna run this. And there you go. Excuse me. Voila. So there you go. You can filter this using web, or you can filter this using purchase list, whatever. Okay, this is great. Now, client comes back to say, look, this is great, but I wanted to do multi-select, right? I wanted to do multi-select. Right now, it's a radio box, which is great, but I wanted to do using check boxes. Can we do that? Absolutely. Okay, so what we're going to do, we go to edit, and go to lead source, and go to query, and there's something called selection type, and make it to multiple selection, save it, and save it here, and there you are. You can do multi-select here. Let's say partner, let's say web. Fantastic, right? Sounds great. Cool. Now, we got different filters as well. You can filter using date. So if you wanted to filter using date, you can draw the date here, and you can add the create date, and you can filter it, right? That's one stuff, which is great. Now, what I wanted to do, I wanted to show you how to move back and forth between different pages. You can create different page here. So we're gonna get rid of this. So there's something called plus button here, right next to the main page. Click here, and we'll take you to edit page name. So I'm gonna name it as second page, and then add. So what we're gonna do, we're gonna create a chart here. So I'm gonna drop it here. Just gonna make it bigger, and so I'm gonna use the same data set. So I'm gonna add annual revenue, and I don't want this count number of rows. I'm gonna delete it, and I'm gonna add bars to lead source, right? It's pretty fantastic. And if you wanted to change the table to table mode, you can do that as well, right? I just wanted to do this way. Cool, sounds good. Okay, I'm gonna save it. All right, now watch what happens. I go here, and I save it, and I just wanted to run this. Right. Now, you might wonder, what the heck is it? I've just created a second page. Where is it? Right? So the reason why you can't see the second page because there's no link between the first and second page. So I'm going to show you how to add a link so you can go back and forth. Right? Sounds straightforward. Okay, so go to edit again, and there is something called link here, right? And drag and drop here, link, and change the bottom title to second page because we are on the main page. So it should say that second page because it takes you to the second page. And link to, we're not using lens, we're using the page. So choose the second page and save. Right? Now that's great. It will take you to the second page. Now you need to come back from a second page as well, right? Because you are here, but how do you go back to the main page? Right? So you need to add another link here, so which connects to the main page. So I'm gonna drag here, and it's gonna go to just type main. It's a main page. Link to page because it's not a lens, so we do this and save. Fantastic. Okay, now there's something I wanted to pay attention to. Move, excuse me, move and add. So what happens? There's a difference between two, although both of them perform similarly, except there's a difference. So if you do move the page, right? I choose this chart and say move the page, right? And it will move to what's that called? To whatever the page you choose to move, right? So the chart will be removed from this page, it will be moved to another page. That's great. Now when you do add to page, it will move the chart to another page, but it will not remove the chart from an existing page. Let's say I wanted to move this chart to the main page. When I use add page, it will keep the chart as such on the secondary page, but it will move the page to the main page, like it will create a copy on a new page, right? That's all it is. Okay, so we have done with the linkage here. That's great. Now let's save, and then let's run it. Okay, let's go to main page, and let's run through this preview. Voila, you got a second page, right? You're gonna go here, and can we go back main page? Fantastic. Let me add a filter here. I want to do only web. Right, okay, I want to do web in this, right? Just nice and easy. Here you are, it filtered here. Fantastic, right? So this pretty much I wanted to cover today. I wanted to keep this session shorter in terms of Einstein. Okay, so this all I wanted to cover. So if you wanted to play around with other widgets, you're most welcome to do so. So there are a lot of options here. You have navigation here, you have toggle here, you have text. Play around with it. If you have some questions, please put that in the comments below. I will try to answer as much as I can. Right, cool. All right, now comes to the second part of it. Now we're going to talk about machine learning, right? So let's close this boy here. Okay, so if you are not interested in machine learning, you can jump off, that's fine. Because today's machine learning will be a bit rough, because the reason why I'm saying rough, it will be more on mathematics sides. Because if you are someone who wants to learn machine learning, you need to understand a math side of it as well. I try to make it as simple as I can, right? You need to understand a bit of differential equations. So if you have done calculus in your high school, it will come handy, or if you don't remember, that's fine, you can recall it. So if you think that machine learning is going to be a bit rough and dry, please, it's fine, you don't have to attend, right? So before you leave, if you haven't subscribed to my channel, please, you're most welcome to do so. Cool. All right, cool, sounds good. Let's jump into machine learning. Okay, so let me open this Paint here. Unfortunately, I still have to use this because I'll try my best to make it as simple as I can. Okay, so what happened last time, right? We talked about two things, unsupervised and supervised, right? Right, so supervised, as usually you know, you have a model, right? And you got a model, right? And you train this with a labeled data set, right? X1, X2, right? And you get Yn, right? And so a labeled data set means you already know what's the output going to looks like based on the feature set, right? So now that's great. And then we have something called unsupervised, where you have no clue what's the data set looks like, right? Because something like this, and as I mentioned, and your model has no clue about the data because it's never seen the data before. So it's up to the model to put it into clusters or association, right? That's great. Now, fantastic. Now, we have, what we've done, so we have, we talked about the linear equation, right? So y equals to wx plus b, where b is the bias, or you can say intercept, right? Where w you can use it as a slope, right? If you go back to your school's linear algebra. Okay, so what we're gonna do, we're gonna do this here. Okay, I'm just gonna make it very simple here. Okay, just x, this is y. All right, now we drawn the points here. Let me draw some points here just to, and we did something like this last time or something, and we said this is b, which is the bias. Okay, now let's have points here. Now we talked about the loss function, right? Because the loss is something like the model thinks that your value is here. Let's say it is 1, right? And this is 1, and this is 2, and this is again 1, right? And this is something, right? Okay, so, all right, you know what? Let me get rid of this. Sorry about that. I just wanted to make it easier. I don't want to complicate it. Okay, all right. So think about this one. So the model thinks that the value should be here, and actual value is here. So the value of y, let's say value of y equal to 1, and this is the actual value, and the predicted value by model we mark it as, so y1 y dash, right, equals to say 1, which is great. And let's say the value of y, the model says the value of y is here, which is like let's say it's 3, right? And the actual value is here, right? Which is 2. So what does the model says? The model says your actual value is equal to 2, but your predicted value equals to 3, which is, so there is a loss, right? There's a loss of 1, because so usually and similar, because loss is always in positive, so this is a loss, right? There's a difference between this value, that's a loss, these two values, right? That's considered loss. And similarly, the model predicts that value should be here, but actually the value is here, so that there's a loss of this, right? So how the loss function works, right, which is called mean squared loss, what we have. So usually the loss will be y minus y dash, right, squared. This is summation of n. N. Oh, come on, let me tidy this up. My apologies if the math is a bit on the confusing side, but stay with me. I'll try to explain as much as I can, right? I know it can be complicated, but that's fine for now, right? 1 times n, right? So this is what we're going to talk about. This is the way the squared loss is calculated. So what happens is we now, if we need to find a model, right, which fits properly. Fits properly means where the value of this is very low, where the loss is low. Let's say sum of squared losses, right? If you're getting a sum of squared losses is 100, and you're come on, and that's not great. So you need to work out the sum of squared losses to minimize it. What I meant by that, let's say, give you a very simple example. Forget about the sum of all of it, right, for now. Let's take one classic example like this, right? So you're expecting the value y to be 2, right? And instead the model says 3. That's fine. It's not big loss. Imagine you are expecting the value of y to be 200, and the model says the value of the y should be like 1,000. Imagine that's a loss of 800, right? That's a massive loss. That's not great. So your model is faulty. You need to work out to find out the right value of the model so the loss is minimized, right? So you need to work out the value of b, which is your intercept, and then the value of m. you can, for now, we can assume the value of m to a certain value. Let's say we put the value of m as 1, right? And then we have to find an iterative process, right? You need to say, oh, well, let me put the value of m to be this, value of y to be, this is the equation, right? Y equals to mx plus b, right? So y dash, okay, right. So now you can say, let's say this is what we call slope, and b is called bias or intercept, right? And then x is your feature set and y is the value you wanted to calculate, right? So the y, what you're getting, you need to find it such a way that it matches to the actual expected value, right? If there's a difference between there's a huge difference between an expected and the actual value, that's called a loss, right? So how do you do that? We use gradient descent. Gradient descent is very commonly used algorithm. So right, it is it's an optimized iterative algorithm process, right? Where you find you know, where your algorithm works in such a way that you will find calculate the minimum loss. Cool, right? So what I meant by that, so let me draw this here. All right, okay, we're gonna use differential equation here. So let me calculate b, that is your intercept, and this is the sum of squared loss, right? This is what, okay? Now what we're gonna do, so we're gonna draw this. Sorry, I'm not too comfortable using with this tablet, but yeah, try my best. Okay, so we need to find out the loss here. Now value of b should be somewhere here, so that the loss will be minimized, right? Imagine if the value of b is somewhere here, right? Let's say you start with the value of b, so let's say 0, 1, 2, 3, whatever, right? So right now it starts with 0, so right, and let's say the loss is here, right? Right, so that means when the b value of b is here, this is values here, let's say it's coming like this, right? Let's say the value of sum of squared is here. That's a huge loss, right? This is not a good, so let's say it's 1000, right? And so what we have to do, we have to find an iterative process, right? So that your value comes here, then here, we find out, let's say your value of b somewhere here, right? Then the square losses value somewhere here, and then let's say the value of b is here, then the value of your square losses will be here. So what I meant by that, you know, as you change the value of intercept, you see the loss value will change. You know, when it's away from, this is called a minima, where the loss is the curved, where it's flat, right? Like this. And this is where the minimum location they try to achieve, right? And so what happens is that when you start from here, it will take bigger step as it's away from the you know, this the minimum value. But as it come close, like it takes here, then it takes here, then it, as it come closer, it started taking small baby step, right? In gradient descent, so it will, now you might wonder, will it, since it's an iterative process, right? It's, you know, it start here, it start here, it start here, start here. Will it even stop, right? There is a limitation. I believe if it's more than 1000, it will stop. The gradient descent will stop, right? So you can implement this using Python. So when you're using a programming library, right, you don't have to code it manually, everything. There is inbuilt libraries, you can use it, right? But you need to understand the underlying concept before you jump into any of this stuff, right? So let me clean this up first, and we're gonna do some calculation. So I hope that's clear for you guys, that we're going to use gradient descent. It's an iterative process, right? We need to find out the minimum value of the sum of square, right? So, and based on the value of your slope and intercept, right? So that's the value. Once you found it, we can actually, you know, draw it here. You know, if it can be here, it can be here, we'll figure out, right? So what we're going to do, so we need to, we need to find the sum of, so we have loss function, right? Let's say L1. Let's calculate L1 first. we have L1, L2, and L3, just to make it simple, right? Y minus, and the value of y dash is what? It's m times x1 plus b, right? And this is squared, right? And this is equal to y1 minus m times x2, I'll just keep it b1 plus b2 square equals to y1 minus m of x3 plus b3 square, right? Okay, let's bring this boy down here. Okay, so let's say L1. We worry about L1. So if you can solve L1, you can figure out L2. So let's say the value of y1 is 2 here, right? 2 minus, and let's say we assume the slope value is 1, right? And let's say the value of x1 feature is 1 here, right? Okay, and then we have value of b, okay, right? And we have 2, right? Okay, now we're gonna have to do differential equation of it, d of db, right? And we're gonna do 2 minus 1 times 1, which is 1, right? 1 plus b. Okay, right? Now, you know how to do that? It's pretty straightforward. So we're gonna use the chain rule. So if you know the chain rule, so what we're gonna do, we're gonna take the differential equation of whole, and then we take the differential equation of inner. So differential equation of whole, right? So you're gonna do 2 times, right? 2 minus 1 plus b, okay, times, right? Now we're gonna do the differential equation of this. So differential equation of this, so d by dx of this will become 0, right? So this become minus, right? So this will become 2 times 2 minus b times minus 1, right? This is what it becomes, right? Let's say, right, similarly you can calculate L2, then L3, right? Similarly, you can, we have only calculated L1, so you can calculate L2, you can calculate L3. Let's say the value of L1 comes up, just assume, right? I'm not dealing with calculation. Let's say the value of L1 comes to be the first value of L1, and L2 and L3 comes out to be, sum of all these values comes out to be, let's say 3.8, right? Okay, now let's go back. Let me clean this one first. All right, I hope this is clear. I'm going to clear all of this stuff here, right? So just to make you space. So what I did, right? So we calculated L1. We did a differential equation of L1, and we assumed the value of m as 1, right? Because we are not calculating both m and that is slope or intercept. We are only dealing with intercept for now, right? Just to make it simplified, just to give you clear indication of how it works, right? So we calculate a value of L1, and then we calculate similarly the value of L2, L3, right? So now what is the total loss? Total loss equals to L1 plus L2 plus L3 plus so on, right? Let me draw this here. I hope this is clear, and if it's not clear, please go and watch my video again, right? So let me clear this again. Sorry, this is a very small space. I mean, I wish to have a blackboard like they do in MIT, so I don't have it, sorry. I'm just teaching on a small tablet, so my apologies for that. So L equals to, right, L1 plus L2 upon Ln, right? So we calculate the value of L. So let's say the value of L comes here, right? Right? Oh, come on. Right? So remember we calculate the value of L1 equals to something minus 2, 1, minus b, something, right? So let's say we start with the value of b as 0, right? We start with here, right? And then with the value of total L, similarly we substitute for L2, we substitute for L3. So let's say L1 equals to whatever, right? L equals to L1 plus L2 plus blah blah blah, and then it returns to 3.8 total. Assume it for now. So value of b is here, and it's 3.8 here, right? This is 3.8. Right, so is this a good loss function? No, absolutely not. Right, okay, now try it again. substitute the, okay, now what we're gonna do, so we gonna substitute the value of b next time with 3.8, right? Let's substitute the value of b with 3.8. Okay, so we're gonna substitute the value of before we do that, we're just gonna multiply this with the learning rate as 0.01, right? So we're gonna have 3.8 times 0.01, right? This is comes again 0.38, right? Something like that. Okay. So we're gonna substitute now this one to the value of b in the other equation, like we had like -2, 1 minus b, right? So substitute the value of b with this one, right? Okay. So what happens is that let's say you got a value of b this time is minus 3.8, right? So we're gonna have the b value as 3.8 here, right? So we're gonna start it here, right? And then so let's say the value of L1 comes to be something like here, right? So we moved here. So this is the slope here. So we move the value of L here, right? Then increase the value of b again, right? So let's increase the value of again. So it moves the value of b forward, right? And then your value of b loss function will come here. So it comes here. Then again, they increase the value of b. So finally the b will reach here, right? B will reach here, say, let's say the value of b is something like, say 2.2. Let's say this is the value of b. And then where you have the perfect value of the loss, right? Let's say it's 1.2 something, right? Now, come to this boy here. This is where you draw the line. Now, what we're gonna do, we're gonna start with here, 2.1. So you see, it's gonna go mostly. So what it does, it covered most of the slides, most of the points here. So this is how you calculate the optimum value of the b. So this is one of the I try to do in a very, very simple way. I mean, you can do lots of complex equation, right? I try to explain. So what we did, I'll recap it just right now, what we did. So let me clear this one. So it's very simple, right? You can, okay, hang on. Let me clear this one. So we use the gradient descent, right? Gradient descent is very efficient to the computation. There is something called ordinary least square, where you can work out the value of the actual intercept and slope, but that's much slower compared to gradient descent, right? So if you're using gradient descent is useful when the data set is bigger. When your data set is very small, then you can use ordinary least square. Way to figure out to calculate the least loss, value. It's called actually a cost function, right? You need to minimize the value of a cost function or the loss function, right? So what we're gonna do? So what we have done, right? So we got this equation, right? Y equals to mx plus b, right? And now we use the gradient descent here. Come on. Sorry about that. That's just epic. Okay. All right. This is the sum of square, the loss square, right? Okay. And this is the intercept. So we have the value here, something like this, right? We need to find this value of this. So obviously, your gradient descent has to work out to find the least minimum local value, right? So we start with here, right? And then it moved here. So come on. So then we moved here. So the value of loss decreased here. Then we moved here. If you notice that when it's far away from the local minimum, right, it takes the biggest step, right? And the learning, so you need to multiply this with the learning rate. So whatever the value of L you get, right? So you need to multiply with the learning rate. So if you choose a bigger learning rate, so what happens is that it will, let's say, right, if you are choosing the, if the rate is bigger, right, it goes like this. then what happened, it might miss the actual minimum here, then it overshoots it and goes up, right? So you need to be very careful with that. So you need to decide, you need to choose your learning rate very wisely, right? So that's one of the things you need to pay attention to. So, right, so yeah, we move forward here, we move forward here, we move forward here, right? As you can see that the value of the b, and then you will find out the value of b. Let's say you moved here, and the loss function is here, which is not really an optimum one, and you moved here. So the as you move closer, you know, the steps, what it takes will be very, very smaller, right? So that's how the gradient descent algorithm works. The more you further you are away from this the local minimum value, the bigger the step will be. The more closer you get, right? The more closer you get, yeah, the steps will become very small like this. If you are here, it will take bigger step, then you get smaller, then you get smaller, right? Because you should not be getting a bigger value, right? You overshoot it, then what happened? It actually missed the value. So you have to watch out, you have to play around. So you need to, so what I suggest you to, please go and read the gradient descent algorithm, right? If you don't understand, please just send me a message. I will try to explain again, right? This is the very simplest way I can try to explain. If you're someone who came from Python, like you have inbuilt functions, you can use it, right? So yeah, and this is one of the easiest way I can try to explain. And now we might, so machine learning in Einstein, right? Uses different algorithm under the hood. So it's very important for you to understand, if you wanted to be a machine learning practitioner, how to use it. And please encourage you to study differential equation. I will start with differential equation in 10 p.m. university, but tomorrow I'm going to start with mathematics. In 10 p.m. university, I'm going to start with the very basic mathematics, right? You need just addition, subtraction. I wanted to start with the basics so I can include the high school kids as well. Then we're going to talk about linear algebra, differential equation, integration. You need to understand differential equation if you wanted to know machine learning. Just by using tool is not good enough, right? You need to understand. I'm not a I don't have statistic degree. I have engineering degree. So I can do maths. So I've learned complex mathematics is my engineering. So, you know, starting from differential equation to Laplace theorems and kind of Fourier transformation, you name it, right? So yeah, I mean, so if you find this maths very complicated, I will encourage you to check out, there's something called Khan Academy. That's a very good resource as well, right? So yeah, I try my best to cover as simple as I can. My apologies if it's get overwhelmed. So our main point, as I said, to find out the, you know, the best way to minimize the loss, right? So we have to use the gradient descent for that, so that, you know, it's a repetitive step. So we need to work out the intercept, and you need to use the quadratic differential equations on each loss function, and you substitute the value of b. You know, you can start with any value, right? You can start with 0 and then, you know, go forward. So right, that's all I wanted to cover today. So if you have any questions or comments, please leave below. If you think that this video hasn't covered much, please let me know so I can improve next time, right? That's all I wanted to cover today, guys. I hope you're having an amazing day wherever you are. Greetings and adios from New Zealand. Bye bye.